So yesterday we talked about ionic bonding. Today we're going to talk about covalent bonding. Covalent bonding is formed by the sharing of electrons. So remember, we are sharing electrons. More than one electron can be shared, and electrons can be shared from more than two different atoms. There are diatomic molecules. That's a molecule formed from two atoms of the same element. Okay, so you have two atoms of the same element. So first thing, for a covalent bond, you have to draw out your Lewis dot structures, right? And we know that fluorine has a -1 oxidation number, right? Okay, so fluorine has 7 valence electrons, all right? And on the other fluorine, you will either use, I use X's because I don't use two different colors, but you can use two different colors. I'm perfectly fine with that. But you have to show that these electrons are different, all right? And for covalent bonding, what you have to do is circle the shared pair. So now everybody's happy at 8. So the second example would be oxygen. Oxygen has a -2 oxidation number. And you're going to draw your Lewis dot structures again, right? So you'll have 2 oxygen. Now, for the Lewis dot structures, you want to make it easy on your circling. So you can rearrange the electrons, okay? So for oxygen, since we're sharing 2 electrons with each other, it's easier to arrange them like this, and then you circle the shared pair. And then you're done, right? Okay. Now, the sharing of electrons is not always equal. So, we have polar covalent bonds. Polar covalent bonds are the unequal sharing of electrons. You need to remember that polar is unequal. Okay, so polar, unequal sharing of electrons, resulting in an atom slightly negative and another slightly positive. So an example would be H2O, which is water. Okay, so to draw this covalent bond, it's the same as it was before. You have 1 oxygen in the middle, then you have a hydrogen off to the side, hydrogen off to the side. Okay. So let's make oxygen our X's, and we'll make hydrogen our dots, and then you circle the shared pair. Now everybody's happy. Hydrogen's happy with 2, oxygen's happy with 8. Now, there are nonpolar covalent bonds as well. And nonpolar, the electrons are shared equally. So polar is unequal, nonpolar is equal. Okay? Polar, unequal, nonpolar, equal. So, carbon dioxide, CO2, carbon has a, it'll be a -4 oxidation number. And oxygen is a -2. Now remember, with covalent bonds, all of your ions are going to be negative. Okay, so all ions are negative. So you're going to put carbon in the middle, okay? And like I said, you can rearrange the electrons on the Lewis dot structure to help with ease of the circling, okay? And you're going to put oxygen on either side. They're both sharing 2 electrons each. So both oxygens are sharing 2 apiece. Carbon is sharing all 4 of its electrons. So those 2 electrons from carbon are sharing with this oxygen, and then the other 2 are going to share with the other oxygen. And that is how you do a covalent bond.